Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. In today's episode of our AI in Sports series, I'm joined by Mike Schumacher, Director of Business Analytics for the Portland Trail Blazers, and Chenhui Hu, a data scientist at Microsoft. In our conversation, Mike, Chenhui, and I discuss how the Blazers are using machine learning to produce better targeted sales campaigns for both single game and season ticket buyers. Mike described some of the early use cases the Trailblazers explored in their drive to apply analytics and machine learning to the process of increasing ticket sales. And Chenhui elaborates on some of the unique challenges of the Trailblazers dataset and the modeling techniques the team applied to solve their problem. All right, let's do it. All right, everyone. I am on the line with a couple of guests that I've been looking forward to speaking with. I've got Mike Schumacher, who is Director of Business Analytics with the Portland Trail Blazers basketball team, and Chenhui Hu, who is a data scientist at Microsoft. Mike and Chenhui, welcome to This Week in Machine Learning and AI.
Hi, Sam. Thanks for having us.
Yeah, thanks for having me.
Absolutely. Why don't we, in the tradition of the podcast, get started by having the two of you introduce yourselves. Mike, how did you get involved in analytics and machine learning?
Sure. So my career started in software development. I got my master's in enterprise software architecture and was an application developer for 12 years before coming to the Blazers. In those first few years before I made it to the Blazers, a lot of my work shifted from pure development over to data warehousing, business intelligence, data analysis, data viz, those types of things. And my first few years with the Blazers was heavily focused on data management, getting our data warehouse set up, marketing automation, CRM. And as our systems and processes became, more sophisticated, we started looking into machine learning and more predictive analytics. And that's kind of where we're at today.
Okay, great. And Chenhui?
Hi, I'm a data scientist at Microsoft AI and Research in Boston. I joined Microsoft last year, and my current interest is to solve prediction and optimization problems in retail, marketing, and manufacturing. Before that, I finished my PhD study focusing on medical image data mining. That's pretty much my brief background.
Awesome. So Mike, my producer who stays on top of these things tells me that a good place to start is to congratulate you for putting quite the smackdown on the Phoenix Suns on opening night.
Yeah, did not see that coming, especially with one of our best players sitting the game out. So that was unexpected, but a very pleasant surprise for sure.
Absolutely. Why don't we get started by having you tell us a little bit about some of the applications for analytics at the Blazers and how that has grown to involve machine learning?
Sure. Yeah, we spend a lot of time working with various departments across the organization. We're almost like the data police at times. There's a lot of data warehousing that we do. We have integrations between different systems. We help with any type of data analytics project a department might need, help them use data to make better business decisions. And so that's kind of the basis of our group. We do a lot with CRM, marketing automation, a lot of one-off projects where we're presented with a problem and we go out and do the analysis to try to help make a decision on something. And so that's kind of where we started. And as our foundation has grown and we've been able to build out that foundation with the data warehouse, we've started to reach out into some of these other areas like the predictive analytics and the machine learning. And that's where we decided to partner with Microsoft. We went over and did some use cases with them, and they've turned out pretty successfully. And so we've been moving in that direction.
And how many people on the analytics team there?
We have 6 on our analytics team right now.
Okay. And do you get involved in both front office types of use cases as well as back office player analytics and that kind of thing?
We have 2 sides of the business. Our team in particular focuses on the business side. There is also some basketball analytics, but our team isn't as involved with those.
Okay. All right, great. So maybe we can start out by having you walk through one of the early use cases for machine learning with the team.
Sure. Yeah. When we first talked to Microsoft, we looked at how things came from in the past, and so we used data in the past to run some of our sales campaigns, but a lot of times we didn't have all the data we would need to set the campaign up the way we would like to. And so what we wanted to do was we wanted to come to Microsoft, give them access to some of our ticketing data, some of our sales data, and ask them to help us identify patterns that would allow us to target people in the right way. So we have over 200,000 people that have purchased tickets in the past, and we can't reach out to every single one of them and give them a phone call and talk to them about if they'd be interested in coming out for another game. And so the idea is we wanted to use the data to determine who would be best to talk to, who else might be best just to be reached out to via an email or some sort of marketing automation campaign. And so that's kind of the use case that we went to them with.
So you do have folks that are actively outbound dialing out to past ticket purchasers to try to get them to buy tickets for an upcoming game via the phone?
Yes, absolutely. We have a sales team that's working with new customers. We also have a service team that nurtures the season ticket holders and helps them maintain a relationship with those ongoing buyers.
Okay. And so what were some of the first steps in tackling this challenge, which is ultimately it sounds like trying to sell more tickets?
Yeah. The tactic that we went with was we wanted to make the data points that we had available that we thought were predictive in understanding who would be interested in buying tickets again, make that available to Microsoft, try to kind of stay hands off with in terms of our bias of not necessarily bias, but our history of what we thought was the type of person we should be targeting, and give them that data, allow the machine learning to look at all the different data points and how they interact and help us essentially score the customers and identify who would be a potential customer again.
Okay. So Chenhui, when this project kind of landed on your desk, how did you approach it from the Microsoft perspective?
So I joined this project, I think, in the second phase. So initially, my colleague has been working with Trailblazers on two different use cases. One targeting at predicting the seasonal ticket sales. The other is targeting the single game ticket sales prediction. And I imported the first use case to a new environment called Azure Machine Learning Workbench, which allows data scientists to do a lot of data preparation and develop models, experiments, and then deploy them at cloud scale very conveniently. So we kind of like improved our original work in this new environment and then made a demo in the Ignite conference this September.
And so was that primarily for the first use case or the second, or did you have the same couple of steps with both use cases?
For now, we only imported the first use case. But yeah, if time permitted, we can also do the same thing for the second one.
Okay. And so what were some of the early findings with that first use case? Did you find that there are any unique challenges associated with either the problem or the data set that the Blazers brought you?
Of course, yeah. I think there are at least two unique challenges in this project. First of all, we need to combine different data sources to profile each customer. For example, we have data from Trailblazers describing the demographic information, customer status, customer interests, purchasing patterns, attendance information, and even team preferences. And then on the other side, we have the third-party data from Axon, which pretty much tells about the lifestyle interest, broader interest of each customer. And then we need to also process those data in a Azure SQL database. And then we need to combine the data processing step with the model development step in the new environment, the so-called Azure ML Workbench environment. And then the second challenge is the process of the machine learning model, and then to come up the best machine learning model for prediction. Essentially, I think the simplest way is just to try a bunch of models and then tune the hyperparameters. But it turns out pretty challenging to log the history of all the experiments. But thanks to the new environment we have in the Azure Machine Learning Workbench, we are able to log all the hyperparameters, performance metrics very easily, and then visualize them, easily pick the best model.
Okay, now that's a topic that we've covered on the podcast quite a bit of late, various approaches to hyperparameter optimization. It sounds like what you're describing is some kind of inherent features within the Azure ML platform that allow you to track kind of different runs with different sets of hyperparameters. Like what exactly are you doing there?
So essentially, in the Azure ML Workbench, you can write like a Python script, for example, and then train a machine learning model with different hyperparameters. And it allows you to also log the parameters that you are using and the performance metrics that you end up to have in this model. And then if you later change another set of hyperparameters, you can easily see how the hyperparameter is impacting the performance metrics. It will automatically generate a set of graphs telling you the impact of hyperparameters on each of your performance metrics.
So does it end up being like a sensitivity analysis, or is it maybe more manual than that?
So it's the original goal is like to provide you a purely automatic way to select the model. But of course, this is pretty challenging. For now, I think it's kind of semi-automatic way because you can write another script just to do a parameter sweep, meaning that you try different combination of the parameters and then just run a for loop. And after running this for loop, you end up with the curve that I just described. This curve will show like the impact of the hyperparameters. And then ideally, you can also write another script to pick the optimal model based on certain criterion.
Mm-hmm. Okay, so it sounds like it's giving you some kind of facility to implement your own grid search of the hyperparameter space. What types of models, like what did you learn about the models themselves for this type of problem? And, were there any surprising findings there?
Yeah, so we basically tried many standard classification models. For example, support vector machine logistic regression and boost decision tree random forest model. So first of all, almost all the models perform very almost the same in terms of the accuracy, but the boost decision tree model is slightly better. And in terms of the accuracy and the precision recall, we end up with very high number, something around like 0.98 in our testing experiments. So that's pretty amazing to me at the first time. And then some other findings also are pretty interesting. For example, if we are targeting the prediction of seasonal ticket purchase, the information about historical ticket purchasing pattern, like whether a customer is a single game ticket purchaser, is very important for the prediction. And I think also the amount of money that the customer has spent in the last season is also a strong indicator. Apart from that, the income or the occupation of the customer can also tell us a lot because the seasonal ticket is sort of expensive. Then people has high income may tend to keep purchasing this seasonal ticket.
Those all strike me as fairly intuitive findings. Mike, was there any surprises in the results that you got back from Microsoft?
Yeah, I'd say that there were certainly ones that were intuitive. There were ones that jumped out to us, like specific games or specific sets of numbers of games that a person has attended in the past. It was, it's different combinations of those variables that we hadn't looked at before. A lot of times we're looking at something very specific, like this person purchased, 5 games in the past, so there's someone that's very likely to want to come back to a game the following year. There was just this combination of all these different data points, and then in one of the other use cases, we looked at the Axiom data, so like the demographic, psychographic, lifestyle data that Axiom provided. Data points that we'd never had before. Some of them that are obvious, like watching particular sports channels or those types of things, actually were also predictive in the likelihood of someone purchasing. And so it was pretty cool to see, all these different data points and how they interacted.
Can you give an example of a counterintuitive combination that you saw?
Yeah, for example, there was one, and I'm not sure why, but anyone that had been to a Minnesota Timberwolves game and had a loan that wasn't a credit card, there was a significantly higher likelihood that they would purchase tickets again. Something that
a loan that wasn't a credit. So something totally out of left field that you would not have expected at all. Really interesting.
Yeah. Yep, definitely.
And so how have you used the results of this work? Is this kind of running in production, or how have you integrated into your selling and marketing workflows?
Yeah, for us, it's been we've been trying to prove out the software, I guess you could say. So we've just been getting into the machine learning and predictive analytics. And so what we wanted to do was run through a couple of use cases that we could actually measure the results to see if this is the tool we wanted to go with. And for the first use case we went through, normally on our sales campaigns, we'll convert at about 5% of the leads that we contact. In this particular case, we converted at 25%, and they were purchasing season tickets in general. So, very substantial. We went through and did the second use case and looked at what's the likelihood of a single game buyer coming back the following season. And in general, we get about 16% of our single game buyers back each year for various different reasons. With the models that Microsoft helped us develop, we were able to identify them at a 30% rate versus a 10% rate of those that weren't coming back, and so they were definitely useful.
Can you explain that last point again? Like you were taking the model and then using that to target your outbound calls, and you were able to increase the rate, the return rate for those people that you wouldn't have otherwise, or for that group of people?
Well, we weren't able to. We didn't change the rate at which we were converting them. With our single game buyers, we'll have about 15 to 20,000 people each year that are individual game buyers. With the models, we wanted to use, we wanted to look at and see who was likely to come back. And so Microsoft went through and identified, we identified the top 10%. We said, these are the people that are going to come back. And of that, 30% actually came back, whereas the rest of the group that was identified as unlikely to come back, only 10% came back. So it was essentially showing us that the model was able to identify these people, the people that we were looking for, a lot better than our other the other ways that we were doing this. And so in terms of using that for the future, our eventual goal is to get into a fully automated system where a customer or a fan comes to us, they opt into us either through a previous purchase, they sign up for some sort of sweepstakes, they join an email mailing list or something, and essentially we'd like to be able to pipe them through the models, have them scored, and then determine, what's the best way to work with them. Do we want to get them into some sort of email drip campaign where we, send them newsletters and we nurture them along that way? Should we be sending them sales marketing? Should we be putting them in a call campaign and having a sales rep talk to them? And so essentially we'd like to have it to a fully automated system, but we're still in the early stages just trying to make sure that the tool works the way we want it to.
Mm-hmm. And now Azure ML is kind of a developer tool. How do you envision using that in the context of your various business processes? Would you be developing custom applications around it, or using some interface where you can run reports against it? Have you thought that far about it yet?
Yeah. So on my team, we have an application developer. We have a couple of analysts. We also have people that are focused on CRM and on the marketing and automation side. And the nice thing is they play really well with Microsoft. And so essentially, we have the in-house capabilities to be able to load the data into the models, and with Azure ML, you essentially get like a web service endpoint with the results. And so the idea there would be we would hook up some more ETL and then pipe that data over into our marketing automation system or over into CRM, and then from there use the automations within those systems to move forward with the records.
And then where do you see this going? What are some of the other use cases that you've got in mind for this?
Yeah, aside from like the fully automated scoring system, we're looking at other things. There's some built-in text analysis that we want to get into. We get survey data. We'd like to be able to make that survey data more actionable, be able to look at like the sentiment of the customer and be able to track that over time. We'd also like to look at some things like help on other projects that we look at each year. So one in particular is what we call our drop count model. And that's essentially how many people come to any given game for various reasons, whether it's for staffing or for just understanding what the sales might be for that game, being able to model that out with this system rather than what we had been using in the past. And so there's a variety of different things that we want to get into, some automated and some just one-off situations where we want to use the algorithms to be able to get us more efficient.
And so you ran a couple of use cases. You got some promising early results. You're still kind of in advance of having this fully integrated into the way you do business. What are some of the barriers or impediments that keep you from kind of being all in already?
Time and workload, I guess, which I'm sure you'll hear from a lot of people. No, we got a lot of great resources, but there's a lot of other responsibilities going on. So it's just getting that time to be able to work with it. System integrations have come a long way over time, but there's still development that needs to be set up to integrate between systems. So we're working with a couple of Microsoft products. We're using Tableau for our data visualization, our marketing automation tools, and other system as well. So there's a lot of integrations that need to be set up, and then again, just identifying where we can get the most bang for our buck in the time that we do set up for the development, because there's a lot of projects that this could be worked on or could be used on, but finding the one that would be most useful is also another challenge.
Right. For some of the future use cases, do you envision having Microsoft like similarly do some of the data science pieces of it, the model development, or are you building capacity within the Trailblazers to do that kind of work? And where are you on that maturity curve?
Yeah, well, we're both. We want to continue our partnership with Microsoft because they've been great to work with, but we are building the capacity internally. I have some great people on my team. A couple people in particular are ramping up on this. We have an application developer that is very well versed in the integrations with the different Microsoft systems. He manages our CRM system, which is also Microsoft, and so we have a good setup there. I have an analyst on my team that she's been spending countless hours just going through all the training, all the tutorials. We've had people come out, and so just building up that internally. I'd say we're still in the early phases, and that's probably why it's taken us a little bit longer to get there, because we don't have a full-blown data scientist on our team. But we're certainly working on building that out internally while we continue to work with Microsoft.
Is there a particular skill set that you can identify that's still lacking?
No, not so much. I mean, it's essentially just getting used to the tool, getting used to how it works, understanding the different algorithms. There's a lot of different ways that things can be done, and just gaining that maturity and experience in the data science type of areas.
Right. Now, Chenhui, a question for you. I've looked at Azure ML Studio in the past, and it can be, I think, of the various cloud-based approaches to data science, I think it has an advantage in being pretty approachable, because you can do a lot of GUI, almost WYSIWYG, the type of thing that I think, a lot of people expect from Microsoft. But it's also, often developers and data scientists don't really like that kind of thing. It gets in their way. And I'm wondering, for you as a data scientist that has, deep knowledge of, this tool, like how do you approach problems? Do you approach them within the kind of that GUI construct that is the default for Azure ML, or are there other ways that you use the tools?
Very great question. So actually, I have been using Azure Machine Learning Studio for about a year. So indeed, we have both pros and cons for this product. I think it's a great tool for entry-level data scientists because, as you mentioned, there are like GUIs, and you can drag and draw on the plan, and then you can construct a machine learning experiment very quickly. And then also you can deploy it as a web service. But in the meantime, for senior data scientists, they may want to have more flexibility to control the machine learning model and also maybe do more complex data preparation steps. So that's why recently Microsoft launched a new tool called Azure Machine Learning Workbench, which is primarily for senior data scientists. It's again a data end-to-end data science and advanced analytics solution for data scientists to like prepare data, develop experiments, and deploy models at a cloud scale. But it also allows you to do a lot of things like without using the GUI. You can write everything basically using a Python script or develop the model, compare the model within the Azure ML Workbench, and then you can also deploy it on different sources.
And so is the user experience there, does it offer kind of the notebook paradigm that's becoming pretty popular for this kind of thing, or is it more at the command line and code level?
Yeah, we have both actually. So first of all, if you are familiar with IPython notebook, you can directly jump in to use that in the Workbench environment. If you are more familiar with like Python script or like a command line environment, you can like develop a Python script and run that script through the command line environment. And more importantly, you can also deploy a machine learning model either on a local machine or on a cloud cluster through the command line interface.
And one of the things that the ML Studio does for you is that it's kind of operating at this higher level of abstraction where you've got these building blocks for different types of models. Like you can, drag and drop a random forest block model, for example, and then kind of wire it up with your data. Do you have access to the same kinds of things in the Workbench, or are you rather shifting to kind of your full native Python and scikit-learn and the kind of traditional Python ecosystem tools?
So at this moment, we are kind of shifting towards the Python, IPython notebook, scikit-learn, all kinds of tools, instead of like again providing the GUI.
So we talked about some of the kind of pros and cons of that tool set in general. Were there any challenges or places where you ran into kind of hit a wall or had to change your strategy with regard to which tools you used in solving the specific use cases that you worked on for the Trailblazers?
So for this use case, I would say because we are not trying to analyze like a huge volume of data and then also deploy it as like, for example, Spark as a machine learning model on Spark, the data size is pretty, so far it's not pretty small. So we can do the model development work both on Azure ML Studio and Azure ML Workbench. So the primary goal of improving our work in the new environment is to trying to demonstrate the new capabilities of this Azure ML Workbench.
Okay. So you were able to do the things you needed to do with Studio. Workbench is something that you'd go to if you wanted to scale it up or in terms of the data or wanted to, deploy it out to Spark. And you made deploy some use cases there just to kind of show them this new platform and how it compares to the original?
Yeah, I would say the primary goal is to showcase, but also we want to work with trailblazers in case they want to like move towards the new environment, so that we can like help them understand how to land on the new Azure ML Workbench.
And this question might be a little bit inside basketball, I guess. This is for Chenhui. Are you with the data scientist title, are you in a consulting organization with Microsoft, or are you aligned with a product organization and just, working with, this particular customer because of their profile? Or how did you get involved in working on this project?
Okay. So for my organization, originally, I think we are more tied to the product team, which is called Azure Machine Learning, as you may know already. So we are actually at the Azure Data Science team under the Microsoft AI and Research. So right now, there's I think intersection between both the product team and the research team in Microsoft. So essentially, we want to bring the advanced research results to the product team so that we can develop like machine learning products based on those algorithms. So that's where we came. So we try to stand in the middle and then try to understand both the research results and also the need from the customer about the product.
And are there any research results that you can see playing a role in the types of problems that the Trailblazers are dealing with?
So for me, I'm pretty interested in like reinforcement learning and deep learning as well. So so I was thinking about two different use cases. For example, if we have like a really large amount of data, say like millions or billions records, then we may try to build a model with with deep learning. For now, because of the goal original was trying to proof of concept, so we did not like use, I think, a large volume of data. But later, yeah, if that's the case, we can try deep learning. And then another use case I was thinking about is to use reinforcement learning to learn the behavior of the customers and then try to send them offers which may sound more attractive to them.
Can you walk us through how that might work?
So this is again, so that's based on my intuition. It's not like a very matured idea being discussed with trailblazers, but for me, I think if we want to sell a ticket to your customer, the first step is to predict whether the customer is willing to buy it or not, and then the second step maybe is to determine the best price, right? So in that sense, maybe we need to dynamically change the price according to certain criteria. For example, if there are other competitor like NBA teams offering the same discount to your customer, and then you may offer like at least the same discount, right? So a lot of factors may play a role in this kind of price optimization use case. So I think, again, machine learning, such as reinforcement learning, can be a good tool for solving such complex problem.
So you're thinking that your reinforcement learner would be kind of exploring this state space of like different types of buyers and different prices and things like that, and trying to find an optimal path through that?
Yeah. So essentially what you can control is from, I think it's mainly the price or the discounts you offered to your customer, right? And then the environment that you are sitting in is very complicated. You have competitors, you have your customers may have different background. You cannot control all of this. So that's why we need to use reinforcement learning to dynamically update your price and discount to attract your customer.
And I'm guessing that Azure ML Studio doesn't do reinforcement learning yet.
Yeah, indeed. We don't have like reinforcement learning as like maybe a toolbox, but internally we have like another tool called CNTK, In CNTK, actually, it has a comprehensive set of functionalities. So it also offers you the flexibility to develop reinforcement learning. Actually, I think in the newly released version, it has some tutorial about that.
Mike, before we close things down, are there, if there were three things that you could get from Microsoft in terms of, the way they supported you or their tools, do you have a wish list for them?
Offhand, I can't think of anything. We've been, very excited about the results. I guess just being able to ramp up our internal knowledge, which they've been helpful with, and just getting the ability to spend some more time on these types of projects would be, the two things that we're looking for. In terms of the tool itself, it's been great. There isn't anything at the moment that I can think of that we would add.
Okay. Awesome. And Chenhui, anything else that you would add or would like to share?
I would say that it's a really great experience to work with trailblazers and then to come up with the solution and trying to improve the existing solution that we have built. So I really look forward, continuing working with you in the future.
Cool.
Awesome.
Me too.
Awesome. Well, I really enjoyed chatting with both of you and appreciate you taking the time. Mike, I wish you and the Portland Trailblazers a great season.
Thank you. Appreciate that.
All right. Thanks, guys.
Thank you.
Thank you.
All right, everyone. That's our show for today. For more information on Mike, Chenhui, or any of the topics covered in this episode, head on over to twimlai.com/talk/156. To follow along with the AI in Sports series, visit twimlai.com/AI in Sports. If you're a fan of the pod, we'd like to encourage you to head to iTunes or wherever you listen to podcasts and leave us your 5-star rating and review. They are super helpful as we push to grow the show and the community. As always, thanks so much for listening, and catch you next time.